All right, everyone, this is 7.2 Similar Polygons. You have a do now, and that's more of an opinion-based. I just want to see where your thought process is at in terms of this question. So give me your opinion below, and then I'll look at them when you submit your work. A movie theater screen is in the shape of a rectangle, which is 45 feet wide by 25 feet high. Which of the TV screen formats at the right do you think would show the most complete scene from a movie shown on the theater screen? So remember, you have 45 feet in width and 25 feet high. Okay, and now if we were to convert that into inches, okay, you have to multiply both of those numbers by 12. So that's 540 inches, and 25 times 12 is 300 inches. So this is what we're dealing with the screen. Now, if you take a look, you have two different screen types, 36 over 27 and 36 over 20. So which do you think would fit of these two better on that screen? Okay, so give it a shot. I know we haven't been taught this yet, but let's see if we could figure that out. Vocabulary terms, similar figures. They have the same shape, but not necessarily the same size. Two polygons are similar polygons if their corresponding angles are congruent. Okay, that's important. Corresponding angles are congruent, and the lengths of corresponding sides are proportional. Okay, that's the key word there, proportional. All right, they show proportional right here, actually. Okay, and they're showing you your angle congruency as well. Extended proportions are when three or more proportions are equal. Okay, a scale factor is the ratio of corresponding sides or angles. So if you look in this image, we have 15 corresponds to 6, 20 corresponds to 8, and 25 corresponds to 10, right? So those sides are AB in the blue, corresponds to XY. Okay, and then how do they demonstrate? With equals, correct? So equals, and the proportion or the ratio of our greens, which is BC, corresponds to YZ, which are these lines. They are proportional. And then we have AC, which is 25, corresponds to XZ. And if you notice, if we were to plug in the values, here's A, B, and XY, it's 15 over 6. BC is 20 over 8. And XY is 20, AC over XY is 25 over 10. Now, if we were to type all of these into the calculator and hit enter to simplify them, okay, so you do your alpha y equals enter, you put in 15 over 6 into your calculator. You get 5 over 2. 20 over 8 in your calculator is also 5 over 2. And 25 over 10 is 5 over 2. So your scale factor is 5 over 2. So what are the pairs of congruent angles? Well, if you could see, these shapes are kind of, one is twisted around or flipped over, right? So what I'm going to do is I'm going to slide this out, and I'm going to slide this one down so we can sort of recreate this angle here. Boom. See, when I flip it over, it is very much similar to triangle TRS now. So what are the pairs of congruent sides? Well, T goes with P. R goes with N. And angle S goes with angle M. Okay, so those are your congruent angles. Now it says, what are the extended proportions for the ratios of the corresponding sides? Well, that's where we just kind of went around the triangle and wrote it out. So side TR is proportional, so I shouldn't put a congruency sign, to NP. So TR over NP is equal to, and then I'll change up my color, RS to NM and lastly ST and MP. All right, and that's how you write an extended proportion. Are the polygons similar? If they are, write a similarity statement and give them a scale factor. Okay, so identify the pairs of congruent angles. Well, they already show that with their orange markings, right? So let's just go around and match those up. They tell you that angle M is congruent to angle W, angle J is congruent to angle T, angle K is congruent to angle U, and angle V is congruent to angle L. Now it says compare the ratios of the corresponding sides. Well, what I like to do is I like to make them different colors. So MJ and WT. And these should be in proportion to the rest. So JK and TU. We have KL proportional to UV. KL proportional to UV. Oops. And what else do we got? ML proportional to WV. Now, it says compare the ratios of the corresponding sides. Well, let's see. If we were to replace these with their actual numerical values, MJ is 6, WT is 6. JK is 12, TU is 6. KL is 24, UV is 16. ML is 24, WV is 14. Now, if we were to break these down, 6 over 6 is really just 1 over 1. 12 over 6 is 2 over 1. So already something is wrong because these are not the same. So these are not proportional. Okay, if we continue to work here, 24 over 16, if you plug that into your calculator as a fraction, 24 over 16, it simplifies to 3 over 2. So again, these are different. And 24 over 14 is 12 over 7. So not a single one of these are congruent. So what do you have to do? We'll slash the equal signs, which means they are not proportional. They would all have to be the same. Okay, so identify pairs of congruent angles. Well, again, if I were to take this and flip it over, interruption, guys.
High school roll call page. This is the high school roll call page.
Sorry about that. Unfortunately, you never know when they're going to make test announcements in the morning before school. Identify pairs of congruent angles. Well, now that I've flipped around, A, B, and C.
Roll call. Entire building.
we see that angle E is congruent to angle B, right? As if they pair up here, E and B, 3 and 3. We have F and C and D and A. Okay, so angle F congruent to angle C, angle D congruent to angle A. All right, it says compare the ratios of the corresponding sides. Well, if we follow that pattern, right, we have ED congruent to BA, or proportional, I should say, not congruent, DA. We have EF and BC, so EF is proportional to BC. And then we have FD proportional to CA. Okay, so let's use the numbers that they give us for each of those. ED is 15 over 12. EF with our blue lines, we have 20 over 16. And we have FD over CA, which is 10 over 8. Now, all you have to do is type these in the calculator. 15 over 12 simplifies to 5. Oops, let me do this in red. Simplifies to 5 over 4. 20 over 16 simplifies to 5 over 4. And 10 over 8, if we divide both by 2, also simplifies to 5 over 4. Notice how all of them are the same. That means they are proportional. Your scale factor is 5 over 4. Okay. Using similar polygons. Well, in the original image, they give you two shapes. Okay, and we should be able to clearly see both of them. One is within the other, right? We're trying to figure out if these are similar, if they are in proportion to each other, and they want us to find the value of x, okay? So what I did was I took the smaller of the two and I brought it out by itself, okay? So I slid it out. Now, we are trying to find the value of x, which is side FG. Well, FG is in proportion with BC. Okay, so the way we can write that is that we can write 7.5 over x. And that is equal to, now, we need to find another side within this figure that has a value, okay? So I see right here, ED is 6 over, okay, the entire length is 9. And then all we have to do is cross multiply like we've been doing from last week. 6 times x is 6x. 7.5 times 9 is 67.5. Divide both sides by 6. Okay, and x is equal to 11.25. Okay, it says use the same diagram, and what is the value of y? Well, now you need to discover the top, which is EF, which is congruent to AB. So we have 5 over y is equal to. And again, we can use the same proportion we took before, 6 over 9. So we get 6y equals 45. Divide both sides by 6. And y equals 45 divided by 6 is 7.5. Your class is making a rectangular poster for a rally. The poster's design is 6 inches high by 10 inches wide. The space allowed for the poster is 4 feet high by 8 feet wide. What are the dimensions of the largest poster? Okay, so the first thing you need to do is you need to convert feet into inches, okay? So 4 over 8, you're going to multiply them both by 12 because there are 12 inches in 1 foot. So we get 48 inches, and 18 times 12 is 216 inches. Okay, so 48 by 216 is the space that we are working with. Determine whether the height or the width will fit in the space first. Well, 6 inches over 10 inches is the original. If I keep doubling, we get 12 over 20, 24 over 40, and 48 over 80, right? Because I just kept doubling them. Well, here's 48, and that's the maximum, right? So the height will fill first. So if the greatest height is 48, what is the width? Well, 6 times 8 gives you 48 inches high. So that means you have to take your 10 inches and also multiply it by 8, and you will get 80 inches wide. Okay. The last part's the diagram shows a scale drawing of the Golden Gate Bridge. The distance between the two towers is the main span. What is the actual length? So they're telling you that 1 centimeter is equal to 200 meters. They tell you the length of the main span is 6.4 centimeters. So if 1 centimeter is equal to 200 meters in real life, they're telling us that this bridge in the picture is 6.4 centimeters. How long is it in real life? So again, cross multiply. 1 times x is 1x. 200 times 6.4 is 1280. Divide both sides by 1, and x equals 1280 meters.